So hello guys, today I'm going to solve the question of linked list. The question is basically palindrome linked list. So we have to check basically the given linked list is palindrome or not. Okay. So how we will solve this question? You know the definition of palindrome. Okay. So let's open whiteboard and see how we are going to solve this question. Okay. So basically let's suppose this is a given linked list. This is 1, this is 2, and this is 1, sorry, this is 2, and let's say this is 1, right? And this is a null. So when we will say this is a palindrome, if first and last node is same, the value at the first and last node is same, and the value at the second and the second last is same, and so on. Like this, we will say, yeah, it is palindrome. So how we will approach? The first approach, what we will do, we will uh, take a stack and store all the nodes, right? So just take a pointer here, and we will first push the first element, that is one, and now move pointer ahead, and now pointer is at 2. Now we will push 2. Now pointer will move ahead. Now pointer will reach at 2. Now we will push again 2, and now pointer is reach at the 1, and we will push 1, and for the next time pointer will reach at the end. So now our traversal is finished. Now we have all the elements in a stack, right? So we know that we know that a stack is a work only for last in first out. That means we have a we have put an element that is a last, which will come first, right? So uh, that means the last element of that node or is at the top of the stack, right? So when the top of the element is equals to what, the first element, then it is okay, right? So now what we will do, we again take up another pointer, and we traverse the whole linked list. So during the traversal we compare the element and top of the node, and then pop that element, and then again compare to the next node, and so on. So what we will do, we just take pop the element from the stack. So element is 1, and now we compare, this 1 is equals to 1, yeah, it is okay. So now what we will do, pointer will move ahead, and now we will pop out the second element, means top of the element as the top of the stack. Now it is 2. Now we compare is 2 is 2 is same with 2, yeah, so it is okay. We will move ahead. Now again we will pop the top element, that is again 2. So now we check it is match, this is okay. So pointer will move ahead, and now when we pop out, this is 1, and now this is basically match, last element is also match. That means when all the element is matched, that means given linked list is a palindrome. If one of the element is not matched in the middle of the traversal, then we will say, we will return at that point, no, this is not a palindrome, right? So this is the first approach. So if we talk about the time complexity, so basically, we are traversing two times linked list. So you can say big O of 2n. This is equivalent to big O of n, right? And if we talk about space complexity, so we are taking extra space, a stack space. So this is also a length of n, means that means you can say that is the how many nodes in a linked list. So size of the stack is equals to that. So this is basically a big O of n. Space complexity is also big O of n. So let's code it out first, then we will approach the next approach. So here what we will do, we will take a stack, right? And what we will do, we'll take a stack of integer type, let's say st. Sorry, my bad. st. Then what we will do, we will take a temporary variable temp and store the address of that uh, address of head to the temp. Now, what is our first step? We first store all the element into the stack. So what we will do, we take a while loop. If temp is not is equals to null, then what we will do, st dot push. We will push the that value at the that pointer variable, right? So this is basically temp arrow val. So I have pushed. Then our next step is uh, move the pointer ahead. So temp is equals to temp arrow next. This is the so at the end after this after the when while loop will terminate, we have all the element in a stack. Now what we will do again, we as take the temporary variable and start from head. We start from head, and now we check if while that stack is not empty, then what we will do, we take the top element and compare with that uh, that value which is pointing that you can say that node point temporary variable pointing to that node, right? So what we will do, we just uh, take the top element of the stack. So what we will write, let's say this is data is equals to st dot top, right? And we get data, then after that we have to pop that element from the stack. Now we compare if that data is if is not is equals to that temp data, temp val. In this case, b in this case we get a variable, we get a value that is unmatched. That means this is not a palindrome. So in this situation, we will return just false, right? And suppose this case is not true, then what we will do? We have to move the pointer ahead. So temp is equals to temp arrow next, right? And at the end, then all values match. When all the values match, then that means the given list is palindrome. Then that's it. In that scenario, we have to return true. So let's run it. Yeah, it's working fine. Let's submit it. Yeah. So this is the one of the approach, right? Let's talk about another approach. Let's talk about another approach. So another approach is that if suppose we have a list, a given list, let's say this is 1, this is 2, this is 3, and this is 4, and this is 5. So this is not a palindrome, yeah, because value are not matching from the end. Okay. So one of the approaches, one of the another approaches, basically what we will do, for the sake of confusion, we just take only four. This is a five node. Okay, so just erase the first node. Now it is a oh, four node in a list, right? So what we will do? We first reach the middle of the list. We first reach the middle of the list, and rotate the second part. When we rotate the second part, it will look like 5 and 4. Sorry, my bad. Right? It will look like 5 and 4, and now this is pointing to null, right? Null. Okay. So suppose if we say let's make it palindrome first, then we will get the proper intuition. So if this is 5, if this it will be 5 and it will be 4, then it is a palindrome, right? Right. Okay. So when for our first step is reach at the middle of the list, and this is the first half, this is second half. Reverse the second half. Then after reversing the second half, we have 5, 4. And now we take a two pointer, first pointer at the starting of the first half and second pointer at the starting of the second half, right? Now we compare. Is 5 is equals to 5? Yes. Move ahead. Move ahead. So now it reach at 4. Now 4 is equals to 4. Yes. Move ahead. Now it will reach at n. So this is the another method. So when we and during the checking, when we get any value that is not equal, then we will say, yeah, this is not a palindrome, right? So let's solve it. So basically, for finding the middle node, I will use the approach of tortoise and hare algorithm. So if you don't know about this, no worry. I will solve that question, find the middle of the list and how to reverse the list, these things in a next video, in upcoming video. For the time being, uh, let's see how we can solve. We just erase these codes. So our first method is find the middle of the list. So what we will do, we take a two pointer here, that is one is slow, which has head, and one is fast, which has also head, right? Now what we will do, we will take a while loop and check if fast is not is equals to null, and fast arrow next not is equals to null, then slow is equals to slow arrow next, and fast is equals to fast arrow next. Actually, this is the one of the optimal method for finding the middle of the list. So if you don't know, then no worry about it. I will discuss in upcoming video. For the timing, just understand the intuition and see it's working or not. Right? So at the end, actually what I am doing here, I have taken two pointer fast and slow, right? So let's discuss here. Otherwise you will confuse, right? So suppose this is our list. So what I will do, I have taken two pointer. That is one is slow and one is fast. And both are at the starting of them. That means head at the head, right? So what we will do, we go slow pointer will go one step ahead and fast pointer will go two step ahead at each time. So first time slow will reach here and faster will go two step, then faster will reach here. In the next step, slow is here, and faster is reach at here. And you can see here we have put it condition, we when fast arrow next is null, then we have to stop. So here you can see this is fast, and fast arrow next is basically null. So now we will not go ahead, we will not go ahead, we stop here. So you can see we are at the middle of the we are at the middle of the list. Small is at the middle, sorry, slow is at the middle of the list. So here we get the slow pointer. Now now our goal is, sorry for my bad. So so what I will do here, we got the middle of the node, right? So next step is basically, what was our next step? Next step is reverse the list. So now I'm going to reverse the list. So just make another function for reversing, private, and it will return list node. Mm, hmm. It will return, let's say, name it reverse, and it will take a basically a pointer, that is, let's say, head. So now our goal is reverse the list. So here what we will do, we take a temporary variable, that is one is brave, that is initially pointing to null, and the second one is basically, let's say, current, which is pointing to the head. So this is the function for reversing the algorithm. I will discuss about this video, this in the upcoming video, how to reverse the list. Okay. So now we will take a loop while current is not is equals to null. Then what we will do, we take a new variable, that is list, that is temp, that store the address of next node. So next node will be current arrow next. Now when we get the next node, what we will do, let's see how we can reverse. Uh, you can say this is the first node, this is the second node, right? Now our goal is remove this link, and just this node will point here, and this node will point here. This is the our goal. So it's initially current is at here. So when we break the link, we cannot go ahead. That's why we have to take another pointer to keep the address of next node, right? So that's why I'm taking here the temp variable. Now what I will do, now we know if we reverse the first node is pointing to the null. First node is pointing to the null. So that is the current arrow next. Basically, current arrow next is basically what you can see here. A previous contain the null value. So we can write here prev. And the next case, now we have to move the previous ahead. So prev is equals to cur, and then mm, then what I will do, update the current value with temp. Now temp is pointing to the current is pointing to the next element, and at the end current will reach at the when current will reach at the end, loop will terminate, and that point, that reversed linked list means we got a new head, that is a prev, which is pointing to the head of the new list, right? Reverse list. So here we will return prev. So this is the function for reversing the list, right? So now this will reverse. So we will call, so you can see here when we reach at the second half. So now what we will do, actually a small is here, actually a small is here. So the second half is basically started from here, and the address of this node is nothing but a small arrow next. So I will take another variable that is second half. Available. Hmm. So we will take another value, let's say second half, and uh, we call the function reverse, and we pass the slow arrow next. That is the, we pass the second half we pass the address of second half to the reverse function, and now reverse function will return the reversed list, right? So now we have the first half, we have a second half. So now the address of this node we have given basically head, and the reverse function will return the address of the reverse part, means that means the address of this part. So now our goal is just compare. So what we will do, while let's say here we have to take another variable that is temp, which is initially pointing to the head, right? And now say if head is not null, and second half is not null. Why? We compare if head, sorry, uh not head, basically this is temp, it will be a temp. So basically we will check just temp arrow data. Oh sorry, here in lead code you will most of the time find they are using val instead of data. So temp arrow data, when temp arrow data is not is equals to what, second half data, that means val. In this situation we will return false, otherwise we got the all the elements, right? So in this case we will return true. So let's run and see it is working or not, if there is any error or something went wrong. So let's check. This is basically a slow pointer, this is basically a fast pointer. We check fast, if fast is not null and fast arrow next not null, slow is equals to slow arrow next, okay. Fast is equals to fast arrow next, this is okay. And now list node second half reverse, we pass that slow arrow next, means that means we are at here, and we pass the address of that, okay. So okay, so let's just take a little dry run, then it will be clear, okay. Let's say this is format. In this example, there are format, okay. So this is slow, this is fast. First step, slow will move here. On the first step, fast will reach here. In the second step, slow will here, and fast will reach at the end. So basically what is happening here, slow move one step more, slow move, actually middle part is this one, right? Middle part is this one, slow. So slow pointer must be at this location, but slow move one step ahead. So we have to what we will do instead of this, we first, for handling this case, what we will do, just we say fast pointer go first ahead, go first you, and then after that we slow. So when, let's say, in this case, what I have done here, if we say faster, you go first. So faster will reach here and slow is still here. Now slow will move here, faster is here, and here faster arrow next is equals to null. That means this will move, faster will not go ahead and it will break, and there it will break here. So now it will work now. So let's run. Yeah. So one of the test one test case is working, but another is not, right? So why this is happening? Why this is happening? Let's say constraints number of node in the list in the range of 1 to 10 raised to the power 5. Okay, okay. This is first half reverse list head, basically brave null current head, while current is not null. List head temp is equals to current next is equals to brave, and now brave is equals to the next temp. It is okay, it is okay. And now we will return brave. Okay, it's fine. But how, why they are not giving correct answer? They move the address of this, it will return this. Okay. So what is happening here? When we reverse, yeah. So after this, what we will do actually, what is happening here? Let's see first. Then I will discuss about it. What we will do here, slow, still giving wrong answer. It is false, otherwise it is true. Oh, oh. The mm, blunder mistake is I am not moving the pointers. So basically at here we have to move the temp variable as well as the second half point, right? So temp is equals to temp arrow next, and second half is equals to second half arrow next. So this was a blunder mistake. That's why it is giving wrong answer. Now it's correct. So let's submit it. Any edge case is there? Yeah. When there is only one node, when there is only non-node, in that case, we just return that node. When there is only one node in a linked list, so obviously it is a linked list. So what we will do, we check if head arrow next is equals to null. In this case, we will return yes, it is a palindrome. Yeah, it is working. Let's submit it. Yeah, it's submitted. So this is the second approach, and basically here we are not taking extra space, you can say. So time complexity will be a big of n, and space complexity is big of 1. So this is the second approach to solve, to check how the given linked list is palindrome or not. So we will meet in the with the next